Hi folks, it's Mike Willegal. I'm going to show you, welcome to virtual VCF. I'm going to show you my Selby reproductions and talk a little bit about the Selby computer, spend a few minutes with you. I hope this works out. I've kind of kludged together a video setup. I'm not really set up for it, but here goes anyway. So basically, this is my setup with the Selby 8H. I will now kind of bring it in so you can see a little better what I've actually got here. All right, we're going to start this by booting up the Selby 8H, which there's no, the original Selby 8H, it came out with 4K memory. There was no ROM, no monitor. You basically had to toggle in through the front panel using individual instructions. A bootloader made it very difficult to boot. So like at least one original owner of the Selby 8H, I added on the back a monitor and a PROM I wedged into the, I hacked onto one of the RAM boards. There's 4 1K RAM boards. Each RAM board has 32 1101 chips. So it's a lot of chips, but not much memory. So anyway, to boot this thing, you basically have to toggle in an 8008 jump instruction. Before I put this ROM on here, and I used it a few years without ROMs, I had to toggle in a bootloader. The bootloader was about 40 bytes, more or less. And it took me about 10 minutes to get the machine booted on a good day. On a bad day, it might take me an hour just because I'd made mistakes and whatever. So to boot the machine, I put 1004 into the front panel, which is a jump instruction. So I interrupt the CPU. You can see the interrupt light on. I step. I put in the low address byte. There's a 14-bit address on the 8008, although only 12 bits are used in the 4K Selby 8H. So the first byte is the low address, which is 0 for my monitor, and the second byte is 17. This is all octal, and you can see it's starting to execute instructions, and I'm stepping through it, and I say run. And what happens is it's now running. I can put a no-op instruction in here, and I can interrupt and step through more instructions in the front panel, and I can resume running. So that's kind of the fundamental operation of the front panel. You basically got to toggle in instructions to do anything. So what I have connected to the I/O ports in the Selby. Now the Selby was came out slightly before the more well-known Mark 8. But it had some I/O capability built in. It had 6 8-bit input ports and 8 8-bit output ports. And they came with some, Selby offered for sale, along with the machine, some interfaces. And one of them was the Selby keyboard interface. And I have that here. And you can see it runs through these 12-pin, 12-conductor cables, the 8-bit bus. It's actually 8 bits of data, 1 strobe and 1 ground, although you're better off not using the ground and connecting all your grounds directly back to the power supply, which I've done here. So there's a keyboard interface which connects to a keyboard. There's an audio tape interface which connects to read and write the tape. The actual tape read and write is extremely reliable. They had a expert engineer develop this. It wasn't developed by Nat Wadsworth himself or or any of his people. He hired a guy to develop the tape interface, and it works very good using frequency shift key modulation. On the bottom there, as these 8008 computers start to get into the marketplace, especially the Mark 8, which got a lot of press, people started building onto them, because when they originally came out, they came out with memory and little else. Well, the SCELBI, they had the keyboard interface, they had the cassette interface, they had a teletype interface, and they also had an interface that would display characters on the oscilloscope. But after a while, people started adding peripherals to the, especially to the Mark 8, and the Mark 8 also used the 8008. And it wasn't that hard to adapt things between the Mark 8 and the SCELBI. So what I have in that bottom of those three peripheral boxes is a digital group. Some guys in, a guy out in Denver actually created a video interface for the Mark 8. And there is at least one existing SCELBI that had that adapted to it. So everything I've done here was done back in the day. The monitor I put into the ROM that I use to boot this now was a hacked version of one that was printed up in a Micro 8 newsletter available back in the day. So it was called the Creed monitor. I adapted it. It was originally written for baudit character code. I adapted it to ASCII and my SCELBI I/O interfaces. But essentially it's a Creed monitor, which was available back in the day. And so as you can see, I have a video display over here. And what I'll do is I'll just take a second. I'll jump over to adjust the chair in the video. So I'm I have a so I've got the monitor up, and the way this monitor works, it's very clever. It's 256 bytes, and what you do is you type in a 3-digit octal code that makes up an 8-bit byte. So, and then you give it a command. So if I want to put in 0 in the high address and 0 in the low address, I type 000, high and low, and it displays the memory at that location. Now, to make this demo go a little quicker, I preloaded a program at address 002. And there's the start of the program. And I can increment and decrement through memory. To get that program loaded, the monitor itself does not have a bootloader. But what it does have, because it's very easy to add in, basically edit memory. So I basically typed in, using the monitor, into page 15, a cassette tape read program. And from there, I could read from the cassette tape a program I've already written, and I have a game called Hangman, which I had loaded on tape, and I read in just by typing in this program. It takes me, maybe 5 minutes altogether to type in the cassette tape read routines and then run the tape and read in the program. So at page 2, I have another program. I've got a game in here. So this video output, it's 8 lines at 32 characters. It's the display I'm rather impressed with. It's much better, crisper, maybe because it's less resolution than like an Apple I or Apple II. So it's got a nice crisp display. I'm very impressed with how the digital group guys came up with that board. And one of the shortcomings of this video display is it doesn't really support cursor controls. You can basically write one byte, it'll add that byte to memory. It's basically scanning through memory like any video system. And so as you write to memory, it increments what it's writing. So as I put a 0 here, it's putting a 0 in memory and then increments the location. And so the next 0 goes in the next location and so on. And that goes all through memory, all 256 locations of video memory until it gets to the end, and then it wraps. But there's one cursor control. If you write all ones to the video system, it'll basically set the pointer to the end of memory. It doesn't clear memory, it points it to the end of memory. So you got like a home function. So you can write to memory and you can home, and those are the only two cursor controls. To clear memory, to erase the screen, you've got to write a program that's going to write spaces to all of memory. So that's what's happening when I type L and it refreshes and it prints the memory. I'm actually got a program, the monitor there actually clears all of the video memory, homes it, and then displays the high address, the low address, and the data. So anyway, at this location 2, I've preloaded a game just to save us a little time. And you can see that the SCELBI 8H, if you put some effort into it, as it comes from the factory, it's not very user-friendly, but if you put some effort into it, add a ROM monitor, add a video system, or some kind of I/O system. A lot of people used teletypes back in the day, and SCELBI did offer a teletype interface. It actually becomes useful, but straight from the factory, it's hard to use, hard to get much out of it. So anyway, this monitor allows you to whatever address to execute a program. So if I type X, it's going to start the Hangman program. And this Hangman's a little game. It's kind of the classic game. And it's asking me, do I want to enter and try a new word? And I say yes. And I've got to guess a letter that might be in that word. So I'm going to start with like E. And sure enough, there's an E. So that word is 5 letters with E as the second letter. So I'm going to guess again. I'm going to say maybe a B. And it tells me, nope, I've got one H. And if I make mistakes, let's try J. As I make mistakes, it eventually spells Hangman. When it spells out Hangman, you've lost the game. So I happen to know the first word. And here, so it's spelling out the word. I've got a good guess, another good guess. And you'll notice the screen kind of breaks up when it's refreshing the screen. And that's because when the SCELBI is writing the video memory, it can't update the video. So the video kind of goes on hold. So I happen to know what the first word is. And it's hello. And there I've got the right answer. So I'll try another new word, and this time I'll just get it wrong on purpose, and you'll see how it spells out Hangman. I'm putting K's in, and there's no K in this word. And so it spelled out Hangman, and the real word was computer. So I've got that wrong. Should I try a new word? So that's the little game. So the SCELBI 8H, this is the SCELBI 8H. This is a reproduction, pretty authentic reproduction. It runs with the same chips and equipment as the original. And so that's my little tour of the 8008, and this is what personal computing would have been about in 1974 going on into 1975, just before the Altair came out. There's a long history of the CELBI computer business. They eventually got in, when the Altair come out with the 8080 processor, which was like 10 times faster than 8008, the CELBI computer business, they couldn't compete using an 8008 based machine. They would have had to redesign it. So they ended up going into publishing. They wrote very good manuals. So they ended up publishing a lot of manuals for home computer users, or computer hobbyists, as it was known at the time. And I'll exit the compute program, and I'll come back to the monitor. So that's my little demo of the CELBI computer with a digital group video card, audio tape interface, keyboard interface. Pretty nifty system, and once you get everything together, it's fairly usable. Unlike, you know, the CELBI 8H without all these peripherals, without a monitor. You really need the monitor. Without it, it's really hard to use. It's my VCF demo of the CELBI 8H with digital group video card. There's a lot of fun building this, a lot of challenges involved. Visit my website, www.willegal.net. Follow my blog where I post some of the adventures I run into. And hopefully have a great day and stay safe.